Well, I thought to do a short little video on Speedo converters and getting JDM style cars with UK mile-an-hour Speedo readouts and also speed limiters and various other things like that. I've had to deal with a couple of friends' cars recently, and also I'm currently going through anglicising my own GT4 at the moment. We've got two Speedos here. On the left is the JDM Japanese market Speedo, which is kilometres an hour only, and on the right is the Speedo from a UK GT4. This tends to be the easiest way to sort out a GT4 to get onto UK roads, just to swap the Speedo over. Don't swap the entire cluster over. The actual instrument cluster is wired differently between the UK and the JDM markets, so if you swap them over, something's probably going to go bang. I haven't managed to trace out all the pins on it, but they are significantly different between the two. Also, the lamp locations for certain functions are different as well. I might do another video on that later, because I'm currently sorting out fog lights and whatever on my own. So I've yet to do a video on that. But for the moment, I'm just going to deal with Speedos and Speedo converters. The Speedos themselves tend to be reasonably simple. They've actually just got 4 connections on the back. They have power, ground, a Speedo sense in, and an output to the ECU. This is the JDM Speedo, and you'll see that the UK Speedo is, although the PCB is different, the actual layout of the connectors is exactly the same. So these will actually just unplug and switch between the two. So just undo the 4 screws, pull the Speedo assembly out of the cluster, and swap them over. What I will do though, while I've got both of these out side by side, is just go through how exactly these work and what the differences are between the UK and the JDM Speedo and how they handle the Speedo signal. Okay, so to start with, I'm going to make 3 connections to the Speedo. I've got a ground here, plus 12 volts here, and the Speedo input here. All of these are just being made using the existing screw terminals. I've just made sure the screws are screwed in enough to get a connection. I'm just using crocodile clips off the back of them. Just as a quick note, whenever you're trying to reverse engineer systems like this, it's always worth using, if you can get your hands on one, a current limited supply. This one's, just a fairly cheapy one off eBay. It cost about 60-70 quid, I think, second hand. But it'll do anywhere between 0 and 32 volts and up to 2 amps. So it's reasonable enough for doing this kind of stuff. Also in this instance, I've set my power supply to about 12 and a bit volts, and I've set the current limit to about 1/3 of an amp. That should be sufficient to allow the Speedo to function, but equally if I get something wrong or short something out, with any luck it won't be enough to cause too much damage. So again, just enough to keep things safe. Okay, so here's the front view of the Speedo. I'm now going to turn the power supply on, and not a lot happens, which is not unexpected. However, I've got another ground lead here, and my yellow speed sense input. If I ground these out, not a lot happens. However, if I start tapping these, you'll see the Speedo needle starts to go up. The faster I tap them, the higher the Speedo goes. So, we know roughly how to drive the Speedo. We can send it a pulse train and it will shift the Speedo up. I'm going to automate that because that's going to be a pain in the backside otherwise to try and do for any period of time, and also to do accurately. So what I'm going to do, I'm going to create a simulated Speedo sensor, and I'll show you how I'm going to do that now. Okay, so with this high-tech CAD drawing, I'll explain exactly what we're going to do. We've got a Speedo here, 12 volt line coming in off our power supply, and a ground back to 0 volts. We have the spare pin that we're currently not using at the moment, which goes off to the ECU, and we've got our Speedo input that we know when we ground we can send a pulse to the Speedo and it'll start moving the needle around. So I'm going to use an NPN transistor here, which will allow me to switch this input to ground or not. I'm going to use the emitter and collector of the transistor to bridge the 0 volts and the Speedo input pin. And then on the base of the transistor I'm actually going to attach a signal generator, which will allow me to generate a pulse train into the speedo input, so we can at least simulate what's going on here. We'll stick that on the breadboard and see what happens. Okay, so I have my 2N3904 NPN transistor. I've got a 10k resistor going into the base of it, and you can see the yellow wire just going out to shot there is the collector side of the transistor. That'll go off to the speedo itself, and the blue wire will go off down to down to ground. The orange wire on the right hand side, that's going to go off to my signal generator. I'm also going to feed it through an oscilloscope so we can actually see what's going on, and that allows us to see the pulse trains going into this and then hopefully come out of the speedo as well. Okay, so I'm going to drive this circuit with a Rigol function generator. It basically just generates a series of wave patterns. You can either have sine waves, square waves, ramps, pulses. You can also design your own arbitrary waveforms, so you can actually take that up and essentially load one in from a computer or sample an ABS sensor or something like that, and then replay it so that you can then test out various other bits and pieces. So if you've got an oscilloscope that can actually do digital storage and capture, you can capture the waveform, play it into this thing, and then you can then replay that at various frequencies to simulate how the circuit would actually behave. I'm not using any of the arbitrary waveform generation stuff here. I'm just simply going to get it to generate a square wave. I'm going to get it to generate one at, say, 20 Hz, and then that will then drive that transistor, which in turn will trigger the input to the speedo sensor. So we might as well start it off at, say, 10 Hz. If I turn the output on, we get at least some reading on the speedo itself. As I wind this up, so we'll go like 20 Hz, 30 Hz, 40 Hz, 50 Hz, 60 Hz. You can see we get a proportional increase on the speedo all the way around until we ramp the speedo around to almost faster than it can go. Obviously, if you whiz that at different speeds, you can then set the speedo around to pretty much any speed you like. So we can see that the speed that the speedo reads is proportional to the frequency of the input pulse train. You should also be able to see the odometer spinning around there as well. If you want to put miles on your car, this is a very easy way of doing it. So yeah, we can see that the input pulses are, or rather the frequency of the input pulses, the higher the frequency, the faster the speed that the speedo indicates. Now it's worth, we might as well try and visualise this a little bit so we can see what's going on. If I pan left, I've actually got an oscilloscope here. Focus up a bit more, there we go. This oscilloscope should be reading my input pulse train. The cable coming in here is from the function generator, and then that goes out down to the breadboard below. So we can see as I wind the frequency up and down, you can see that the frequency is reflected on the oscilloscope. So the lower I go, the more spaced out the pulses become, and the lower the speedo shows. So again, as the pulses get close together, up goes the speedo. So if we look back to our schematic again for a minute, what I'm actually going to do now is I'm going to measure what the ECU would see. So on my second trace of the oscilloscope, I'm currently probing on my oscilloscope essentially at this point here. So I've actually got a test point there that my oscilloscope is seeing. I'm now also going to put another test point in at this point here and see what the oscilloscope can see. In this instance, we actually need to pull this line up to 12 volts. So I'm going to put another 10k resistor in here and take that up to my 12 volt line. This will ensure that when there is essentially no pulse, we get 12 volts. When there is a pulse, the speedo can pull this down via an internal transistor to 0 volts. So we can then swing between 0 volts and 12 volts and get that output pulse train. Now unfortunately this is getting a little bit messy here, but you should be able to get the gist of it. This is my line coming from the ECU pin on the back of the speedo. It's going through a 10k resistor up to a plus 12 volt supply. I've got my oscilloscope probe here, and that's probed on the speedo side of it. So in other words, there's going to be a voltage drop across this resistor of 12 volts when the speedo is asserting that transistor, or pulling the line low. When it's not doing that, obviously the oscilloscope's a very, very high impedance, so it will drag the line high, so we'll be able to see the plus 12 volts at that point. So looking at my oscilloscope, you can see the top pulse train there is the output from my signal generator, and the blue trace at the bottom is the output from the speedo. So again, you can see as I move the frequency up and down, the lower frequency exactly apes the upper frequency. So all the way up and down, it pretty much follows it exactly. Now if we tried the same thing on the UK speedo, you would hope that you'd see something different on the speedo output towards the ECU. If there is something that removes the speed limiter, I'd either expect to see the signal being modified in some way, or indeed even just the frequency changing, so that it would be, say, a multiplier or something along those lines. Perhaps it's even just a steady pulse train that's generated to trick the ECU into thinking that something is there or the car is moving at a particular speed. Either way, we'll try it and see what happens. Okay, so I've now got my UKDM speedo hooked up in exactly the same way as I had the JDM one hooked up, and I'm not seeing what I would have expected to have seen on the output to the ECU. It is pretty much matching in exactly the same way as the JDM speedo did, so it's not doing any conversion whatsoever. If you look at the number of pulses that it's creating, they are completely in sync with the input. So although the speedo can go to a much higher frequency, we're now at 200 Hz here, and so we're just over 180 miles an hour, we're not seeing an offset which would in theory trick the ECU into thinking it was going slower and hence not imposing the speed limit. From what I can see, this would only allow you to, you'd end up running into the same speed limiter at about 150, 120 miles an hour or whatever, 110 miles an hour, as you would on a JDM speedo. So I don't think this makes any difference to the speed limiter at all just by fitting a UKDM speedo. I'm going to have to confirm this, but from what I can tell, no difference at all. What I'll try next is a speedo converter, and we'll see the difference that makes, so you can actually see the difference in the pulse trains. But I'm quite surprised at that, because everybody I'd spoken to said, no, just switching the speedos will remove the speed limiter. But I'm not convinced that it will, because the ECU is seeing exactly the same as it would do with a JDM speedo. Okay, so we'll now try the same game again, but with one of the cheapy eBay speedo converters, so you can see what the difference is between the input and the output there. It's a fairly simple little device by the looks of things. There's power into it, looks like a couple of one regulator, a power transistor, a couple of resistors, the odd capacitor, and that's about it really. This has actually just had it comes in a heat shrink sleeve, so I've just stripped that off so we can see what's in it. It looks like a little microcontroller, and that's about it really. So we'll hook it up in exactly the same way. It's designed to sit in between the speedo sensor and the speedo itself. What I'm actually going to do is just plumb it in exactly as if it was a speedo, so give it power, ground, speed in, speed out, and see what we get, and see how similar it looks to the speedo information that we've been getting from the speedo itself. So let's have a look. Okay, so I've got my speedo converter hooked up here. I've got ground, 12 volts power, the input signal from my speed sensor simulator, and the output to what would be the ECU, but it's actually just a pull-up resistor. So we'll run that through the oscilloscope and see what we get. Okay, so I'm going to turn the power on, and I'm going to switch the output for the signal generator on, and there we go. Straight away we've actually got a decent differential pulse train now. So you can see the faster train at the top, so higher frequency, shorter pulses, and below we have proportionately lower pulses. Now if we move that up and down frequency wise, although the pulses are changing width, they are changing width again in a ratio to each other. So the lower set is always a longer and therefore a slower reading on the speedo than the upper train. This makes sense. If you're feeding it with kilometres an hour, if you like, at the top, you should be getting miles an hour pulses out the bottom, even though you've got a speedo that should be reading kilometres an hour. So you're tricking the speedo and therefore also the ECU to show a slower speed. So actually you're reducing it to miles an hour. So if we're putting 100 Hz in at the top, you would expect to see approximately 62 Hz out the bottom. In fact, I might as well get the frequency counter on there so we can measure it. So I've rigged my multimeter up as a frequency counter. You can see it's reading Hertz there. In theory, if I dial in 100 Hz here, we should get approximately 62 miles an hour on the right hand side. So because although this is Hertz, the ratio, it doesn't matter if it's in Hertz, miles an hour, whatever, we're putting kilometres an hour in on the left hand side and we're reading miles an hour on the right hand side. So this is an electrical frequency conversion, which also should be mathematically identical to the kilometres an hour to miles an hour conversion. So if we dial in 50 Hz or 50 kilometres an hour, you'd expect to see 31 miles an hour or thereabouts. And there we go. Likewise, 200 Hz should give us 124 miles an hour, I think. 125, near enough. So yeah, there we go. The speedo converter is definitely doing a conversion. This would mean that the speed limiter that you get from the ECU on a JDM car would certainly be fooled by this. So you essentially remove that speed limit. So you're, rather than speed limiting at 180 kilometers an hour, because you're converting kilometers an hour to miles an hour, you then speed limit at 180 miles an hour. Not that a GT4 is ever going to get that fast, based on the fact it'll probably run out of gears before it gets there. So yeah, this would definitely move on the speed limiter. I was honestly expecting the UK Speedo to do the same thing, but it would appear that it's an ECU difference between the UK and the JDM ECUs, in the sense that the UK ECU does not have a speed limiter within it. Again, there is a difference between the UK and the JDM ECUs based on the fact they have a different fuel map, so I wouldn't at all be surprised if they've actually got other differences as well, such as the difference between the speedo limiters, or speed limiters rather.